Okay, this is the Unit 2 study guide for 7th grade. We have a test coming up this week. So this should hopefully help you prepare. If you can do this study guide well, you will be awesome on the test. If you're making mistakes, not understanding something, remember there's tutoring this Tuesday before the test. The two lines represent the cost of a thermal flask and the more expensive hydro flask. So more expensive, that's going to be important. Label each line with the correct flask. So if I am looking at buying one of each of these, let's say this point is 1, and I go up and I find the point on my line for 1. Looking over this way, which one is going to be more expensive? So if we started at 0, we count by 10, 20, 30, we're just guessing-ish, okay? This one is cheaper, and this one is more expensive. So right here it says more expensive. This would have to be my hydro flask. And this one would be the thermal flask. So it might help to add in some numbers so that you could see what was happening and compare the same points for the same number of items and see what the price was. Okay. The graph shows the cost, C in dollars, of W pounds of bananas, which is a proportional relationship. We can tell because it's a straight line through the origin. Select all the true statements. So all I know so far is that W is the pounds, so it might help to label it to keep things straight. C, this one is the dollars, the cost. So for 6 pounds, because remember this is your X or W, it's going to be 6 pounds, costs me $4.50, because this is my cost. Because it always goes X first and then Y. X is this way, Y is that way. They've chosen different variables, so we can be flexible and use different variables. A says 1 pound of bananas costs 75 cents. Okay, to find that, I could set up a table where I would have W and C, 6 and 4.5, and we could divide. Grab my calculator. To find my constant. And it is, oh, let's put the right numbers in. Do you see that? Typed in the wrong number. This is supposed to be 4.5. Sorry. 4.5 divided by 6 equals 75. So my constant is 75, which means that's also my unit rate. So for 1, it's going to be 75 cents. So for 1, remember this is pounds. This is dollars. 1 pound does cost 75 cents, so that one's true. How about 10 pounds? So extend your table. 10 times 0.75 is going to be 750. So yep, that's also true. Okay, so what about 0.75 pounds? I'm running out of space. I'm going to put my table up here a little bit. 0.75. Oops, let's mess that up. 0.75 times 0.75. Oh, I missed my 5. Equals 0.5625. So not 1. So it's not that. 5 pounds. And we can just keep going. Always multiplying by your constant. That's why we found it, right? The constant is the number you multiply by, or the cost for 1 pound. So 5 times 0.75 is 3.75. So nope, not that one either. How about the 0.43? Is that on the graph? Okay, well that would mean that this is my W and this is my C. So we could continue. If 4 was here times 0.75, would I end up with 3? Yes, so 4 and 3, sorry you can't see that very well, but there's a 4 right there, times my constant is 3. So yes, that one is also on the graph. That means at about right here, it would be 4 and 3. So yeah, you can use a table. When you have a graph, you can take your 2 points, move them into a table, and then divide backwards to find your constant, and then just use that to check other information. Okay, that's it for number 2. 3 says Mario rode his motorcycle at a constant speed. He rode 10 miles in 8 minutes. Which of these equations represents the amount of time, t, and minutes that it takes him to ride a distance of d miles? Okay, so we've got an equation at a constant speed, which tells me it's proportional, so I know it's not going to be this one because we don't ever have adding or subtracting in our proportional equations. Okay, now I just need to find my constant, because it could be any of these. And maybe it's more than one, so we might need to check. So let's see, if we've got the distance and the time, distance is 10 miles in 8 minutes. We're going to divide backwards. 8 divided by 10 is going to equal 0.8. Or, oh man, none of these are in decimal. Okay, let's rewrite this as a fraction. Remember, as a fraction, this is 8 divided by 10, or 8/10. So how do I change this to a reduced? 4/5. Okay. So then my constant is 4/5. So times 4/5 equals that. Okay, so write an equation. Here's my variable. D times 4/5 equals t. Okay, now let's change this to standard form because we got t alone. So we just flip it. T equals 4/5 d, where my constant goes right in front of that variable. Right here. There is my answer. So remember, you can set up a table, assign it some variables, and then you can see what the correct answer is. And remember, the answers are also on the back here, so we could confirm, yep, the answer is C. That's so that you can kind of check yourself as you're going through. All right, the copier was very weird this week, and it copied everything very crooked, but I think we'll manage. So it says, in Canadian coins, 16 quarters is equal in value to 2 toonies. Okay, so you can see they've set up a table. We've got 16 quarters is 2 toonies. We're going to fill in the table to show the proportional relationship. Okay, to do that, I need my constant. So I'm going to start by dividing backwards. 2 divided by 16. Oh, let's type that correctly. 2 divided by 16 equals 0.125. That's my constant. We're not going to round it. We're going to keep that whole thing so that we're accurate. And remember, that's the number that we multiply by. So times 0.125 on each of these. So that means we have 0.125 for 1 quarter. For 20 quarters, we have 2.5 toonies, and for 24 quarters, we have 3 toonies. So we did that. We filled out our table. We showed our work. This is how we got our constant. Oh, and what is the constant? Right there, 0.125. What does the value of 1 mean in this context? That means that it is the value of 1 quarter. So 1 quarter is equal to 0.125 toonies. Or 1/8 of a toonie, as the answer key says. Because remember, I could leave this in decimal, and we could reduce it down to 1/8. So this decimal and this fraction are equivalent to each other, if you want to stay in decimal. Okay, number 5, decide whether or not each equation represents a proportional relationship. The number of marbles each sister gets X when M marbles are shared equally among 4 sisters. So we've got this equation here. To know if it's proportional or not, we could start choosing some values for X. For M. Let's put M over here. And X. And then choose some values. 1. Oh, it's divided by 4. Why don't I pick some easier numbers? Since I get to choose, I'm going to pick numbers I can divide by 4. So divided by 4, we would take this out, and you would do 4 divided by 4. That would equal 1. Again, replace it this time with 12. 12 divided by 4 would equal 3. Continue, take this out, replace it 16 divided by 4 is equal to 4. So whenever you're using an equation, you choose what numbers you want. If it doesn't give you any, choose some, replace that variable, and then see what it equals. Okay? And so then we're going to divide backwards to see if it works. 1 divided by 4 is 0.25. 3 divided by 4 is 0.25. And 16 divided by, oops, sorry, backwards. Come on, Mrs. Maasen. 4 divided by 16 is 0.25. Oh, sheesh, guys. That's not the right number. This should be a 12. Here, let me clean this up for you, too. That should say 4. Okay, that's better. We're dividing backwards on each one of them. We get the same constant, then we know this is proportional. Yes, it is proportional. The constant is 0. Ooh, did you see how I just quit writing constant? Constant is 0.25 or 1/4. Because remember, I could write this as a fraction. 1 divided by 4 would be 1/4. Okay, for this one, I could do the same thing, or I can remember that proportional relationships are only going to have multiplying or dividing. If we have adding or subtracting in them, they're not going to be proportional. And right here, I see there's subtraction. So this is not proportional because there is subtraction. Ooh. Okay, so definitely not proportional right there. If I wanted to check, I could set up a table again where I have L, oops, we have X, and then I have L. I'm always going to put the one that's alone over on that side so that I can just use this one easily. So X would be 1, then we would have 121, right? If I took out this X and I replaced it with 1, 2, and then I would have 1, oh, that's not right. Back it up, sorry. 120 minus 1 is 119. 120 minus 2 is 118. And I could do some quick division to check if this is proportional or not, just to prove that I already knew it wasn't, but I want you to see it. 119 divided by 1 is 119. 118 divided by 2 is 59. So you can see, not the same constant, it is not proportional. So this shows it, explaining that there's subtraction. That also shows it. Okay, this one's getting almost cut off, but we've got our number, so we're okay. It says each of these is proportional. So you're going to fill, for each table, find the missing parts and find the constant of proportionality. So 10 divided by 2 equals 5. That is my constant. So over here, we're multiplying by 5. So 7 times 5 is 35. 1 times 5 is 5. And then remember, to go backwards, you have to divide by your constant. So 15 divided by 5 is 3. So I've got this filled out. My constant equals 5. And we just keep going. 3 divided by 12, divide backwards, which is going to be, I'm not trusting myself, so I'm going to do it real quick. I was pretty sure 0.25, but as much as I've messed up, I thought, grab a calculator, double check. So my constant, because I divided backwards and found it, is 0.25. So that's what I'm going to be multiplying by. So 20 times 0.25 is going to be 5. 1 times 0.25 is going to be 0.25. 10 divided by, to go backwards you have to divide by the constant. So 10 divided by is 40. Yay. Okay, this one, because it cut off, I'm a little short on space, but so I'm going to do my work down here. So this time divide backwards. 3 divided by 5 for my constant is 0.6. That's the number I multiply by. So 10 times 0.6 is 6. 1 times 0.6 is 0.6. And then this one, remember, I have to divide. So I'm going to squeeze it over here because it just doesn't have space. But I have to divide by my constant. Start with 18, divide by your constant. That will tell you what it is for this direction. So I hope you are trying all of these on your own and then just checking or using this when you get stuck. Okay, we've got 3 more problems. We're cruising. Okay, each large adult dog should eat 2 cups of food a day. 2 cups of dog food a day. What are the 2 constants that can be represented by this relationship? So we talked about this, but it's been a little while. You can get 2 different constants, and they are reciprocals of each other depending on how you set up the table. So we're going to set up a table going 2 tables. We've got, and let's call the number of dogs and the cups. So because it says 1 each adult dog. So I'm going to say the dogs is X and my dog food is Y. So cups. So X and Y. So for 1, ooh, they used F and D. F is the food. I should have read all the way. Sorry. This one's F. This one's D. I'll change this. It helps to start it off with the right variables because it makes it easier. So D and F. So 1 dog gets 2 cups of food. So then if I have my F and my D, we flip it the other way. Okay, I have 2 different tables. I can find my constant for each. So for this one, 2 divided by 1 equals 2. So to write my equation, I have D times my constant is going to equal F. This one, again, divide backwards. You're going to get 0.5. So we start with F this time times my constant is equal to D. These are my equations. Then I'm going to just change them to standard form. So right here, we've got F alone, and it equals 2D. This one, I've got D alone, and so I'm just going to flip the number in the front and just follow it by the variable. Those are my 2 equations. Those are my 2 constants. If you switch your table around, you get different constants. Remember, this is also equal to 1/2. 1 divided by 2 is the same as 1 divided by 2. And so these are reciprocals of each other. And so you'll always get a reciprocal when you flip your constant the other direction. So depending on how your table is set up, you get different constants because it changes the way you divide. But that's it. You can set up a table, assign your variables, and put your constant in here. Remember, the standard is y equals kx, and this is my constant. So in this case, we just use the f and d instead. Switch those out. Okay, which graphs could represent a proportional relationship? So to be proportional, you're looking for a straight line, which I think we all know this one really well, that goes through the origin. Okay, here's my origin right there, straight line. So A is proportional. Here's my origin. It goes through the origin, but oof, not a straight line. So this one is not. This one is proportional, origin, straight line. Oh, my origin's way down here. Does that hit my origin? Nope. It is a straight line, but no. Okay, triangle D prime is a scale copy of triangle D. So this one is the copy. This one is my original. And now we're going to find the scale factor and the missing side lengths. So scale factor and missing side lengths. When we did our scale copy, we didn't set up a table, but you can. We hadn't really used tables a lot, but I've noticed that we're really good with tables, but sometimes the scale factor is still throwing us off. So if you put your original here and your copy here, and you match up your corresponding sides. So remember, corresponding sides are the ones that go together. So I have 9.6 and I have 19.2. And then I have 32.6 and 22.4, but I don't know their corresponding parts because they have the question mark. That's what I'm trying to find. I have a table. Scale copies and proportional are the same idea. Your scale factor is the number you multiply by. Your constant is the number you multiply by. So to find my scale factor, I can divide. Let's see if we can get that to show up a little bit. 19.2. I'm going to write it down here since I'm running out of space. Divided by 9.6. equals 2. So my constant is 2. So that would be the number I would multiply by each time. Sorry, my constant, in this case, my scale factor. So find the scale factor. Scale factor equals 2. And then I just have to multiply by my scale factor to find those missing sides. This one is 65.2. And remember, that corresponds with that. So that's this missing side is 65.2 feet. Labeling, it's important. We want to know what they are. And then 22.4 times 2 is 44.8. Label it. So I've got my scale factor, I've got my 2 missing sides. Tables work with scale copies also. This just has a different name. Instead of constant, it is my scale factor. Okay, that's it. Remember, on the back it has all of your answers. And since my copy machine was being really messed up, I didn't get a chance to write in the answers for this one. So if you just want them to see them right here, I'll get that on there right at the end. Because I wrote a little note. See the video? And then this one was 630 and 0.6 because we did that one together. But all the answers are back here, so I recommend you try all the problems before you just look at the answers and watch the video. But good luck. Hopefully this prepares you. Remember, you can come in and visit me as, at tutoring if you need some extra help. Have a great rest of your day.